Students, this is the ALEKS help video for the Distance Learning 8.5 volume of Prisms and Cylinders. Problem number 1, it says draw the left and front views of the solid below. So this is teaching you perspective drawing. So if we were to look going this way at the front, what you would see visually is you would see 3 of the boxes, and then another row of 3, and then the one in the middle. So going from a 3-dimension to a 2-dimension, this is called orthogonal drawing. Orthogonal drawing. That would be the view from the front. And then it asked, what would the view from the left be? So going this way, what you would see is 1, 2, 3, and then of course you would see this, one layer up, and then another layer. So from the left, there would be a row of 3 boxes. And then 2 more to the right at the bottom layer. So it would look from a flat perspective to be an L shape. That's called orthogonal drawing. Taking a look at number 2, find the volume. It's made up of cubes, which means all equal sides. So if you were to visualize one cube here and ask yourself, what's the total volume? If there's one cube and there's a second cube, and of course you go 5 deep, we know that one layer, 2 times 5, is made up of 10 cubes. And then if you have 3 layers of 10 cubes, so this would be 30 cm cubed. Number 3. It says, what is the volume of a rectangular prism? Rectangular prism volume equals base, area of the base, capital B, times the height. So in this case, the base is going to be a square. So it's 3 times 3, and our height is 3. So it ends up being 3 cubed, literally, which is 27, check units, millimeters cubed, or meters cubed. Number 9 said a solid below is made up of small cubes. Each cube has a side length of 1/5 centimeter. 1/5. We want the volume. First off, it asks how many small cubes is the large solid made of? How many cubes total? Well, we have 2 this way. 2 times 5, so each layer has 10 cubes. And we have a total of 4 layers. So, of course, there's 40 cubes. What is the volume of one small cube? One small cube. So the volume is, let's draw ourselves a single cube. We're going to pull it out. So this edge here is 1/5. And because it literally is a cube, we cube that to get the volume. Length times width times height. Exponents. expand, super important. Exponents expand. That's not times by 3. Instead, that's 1/5 times 1/5 times 1/5. So this ends up being 1 over 5 times 5 times 5, which is 1 over 125 centimeters cubed. That is the volume of a single cube. Now, in the large solid, we have a total of 40 cubes. So it's 40 times 1 over 125. That's a single cube. This would be 1 over 125. And you end up with 40 over 125. We're going to reduce, since 40 is divisible by 5 and 125 is divisible by 5. 40 divided by 5, 125 divided by 5. So your actual volume is of the larger rectangular solid is 8/25 centimeters cubed. Number 7, we're going to find the volume of this solid. Now this solid is just simply base times height. Volume equals. Now the bases, there's 2 of them. Remember, they're C, P, R. They're congruent, they're parallel, they're connected by rectangles. In this case, the most common mistake is students assume that this and this are the base. They are not. Instead, it is the front and back shape. Why? Because there's only 2 of them. They're congruent, they're parallel, and they're connected by nothing but rectangles. So our base is this L shape, and the height is the distance between the bases, which we already have as 2. So we're going to find the area of this shape by splitting it up. And split it up vertically. So this edge right here is 6, and that is 8. And that is 7 and 3. So my base area here is 48 and 21. So it's 69 times 2. Complete answer is 138 centimeters cubed. Question 6. Jim carved this solid out of wood. Find the volume of the solid. Step 1, we need to identify our bases. Our bases, they're congruent. There's 2 of them. They're parallel to each other, and they're connected by nothing but rectangles. The bases here would be the front and back I shape. That would be considered the base. So volume equals base times height is the distance between the bases, so it'd be going this way, height. So our base is this L shape. Height is distance between the bases. We already have that. It's times 6. So we're going to slice this up. And we have one rectangle, which is 4 edge, height 8. 4 times 8 is 32. Plus we have this edge, that's 6 and 8. So 6 times 8, that middle one is going to be 48. And then this last one is 4 times 8 again. 32, and we're going to add all these up together. And that will get us our singular base. So 32, 32, 48. So our base area is 112 times 6 will get us our total volume. Total volume of this solid is 672 inches cubed. We're going to find the volume of the triangular prism. Volume equals, again, base times height. Your base here are these front and back triangles. And your height is the distance between the triangles. So we have our height. Our height is 8. To find the area of that base shape, it is base times height over 2. That's a triangle, lowercase, so that's 5, times the 5 over 2 equals 12.5. So 12.5 times 8. So our volume here is going to be 100 feet cubed. A company makes wax candles in the shape of a cylinder. Each candle has a radius of 4 inches and a height of 3 inches. How much wax will the company need to make 120 candles? Use 3.14 for pi. So we're going to draw the candles. They are cylinders. And what we know is it has a radius of 4 and a height of 3 inches. And we want 120 of these candles. So it's 120 times whatever that is. So volume of a cylinder, volume equals base times height. Our base here is not 4. Our base is a circle, which is pi r squared. So we square that 4, we're going to get 16 pi times the height, which is 3. And then we need 120 of them. So 3 times 16 is 48. So we have 120 times 16 times 3, and then times the pi there, which you want to use exactly 3.14. So we need 18,086.4 inches cubed of wax. It says an empty swimming pool needs to be filled to the top. The pool is in the shape of a cylinder with a diameter of 10 meters and a depth of 1.8 meters. Suppose the water is pumped into the pool at a rate of 16 meters cubed per hour. How many hours will it take to fill the empty pool? Use 3.14 for pi. Do not round any intermediate step. Notice it just says hours, so we're going to be rounding to the nearest whole hour. Drawing a cylinder. And we know that the diameter is 10 meters, and the depth of the pool, which would constitute the height, is 1.8 meters. Since it's a fill rate, the first thing we need to do is find our volume, which is area of the base times the height. Our base here is not 10, it's a circle. And because we're having to use it for something else, we're going to go ahead and use a calculator. So it's 5 squared times pi, so that's 25. Times pi, which is 3.14. Times the height, which is 1.8. Do not round in intermediate steps. So the volume right now is 141.3. 141.3 meters cubed. That's the actual volume here. Now, water is going to flow in there at a rate of 16 meters cubed for every hour. So to calculate how many hours will it take, we divide. For every 1 hour, we're going to get 16 meters cubed. So 141.3 meters cubed divided by 16 is where we're going here. So 141.3 divided by 16, and we get approximately 8.8, round to the nearest whole hour, approximately 9 hours it will take to fill that pool up.